So this video is about the concept of dimensional analysis and the tool that is, how we're going to use it throughout the year and what it's valuable for. So first thing is, what is dimensional analysis? It's something that allows us to change the units of a measurement without changing the initial value of the measurement. So we might have made a measurement, but we might have decided that we want to change the units of our measurement so we can compare it to something else a little bit better. So dimensional analysis allows us to go through that process. So what it does is it uses proportions of equivalent values of the units, of the equivalent values of the units to switch. These are what are called conversion factors. So an example of that would be 1 minute is the same as 60 seconds. That's a conversion factor. That is equal to 1. Those are equivalent values. They just have different units. And it's going to allow me to transition from either minutes to seconds or seconds to minutes. Third thing that it's allows us to do, kind of brought this up early, it's allows us to compare two more measurements if they are performed with different units. So if you measure something in meters per second with one person and somebody else measured in kilometers per hour, you can quickly transition and make sure you get an accurate comparison between those two things. The last thing we're going to talk about that it allows us to do is using universal constants to switch from one unit to another. So in chemistry and in physics, there are a lot of universal constants that have a bunch of units embedded with them. And we'll use dimensional analysis to make sure we match up with the correct units that are required to use that constant to get the answer we're looking for. So conversion factors, what are they? Well, they're ratios that are equivalent to 1 and allow for units to change. So they are multiplied by the original value to get the desired unit. So for example, if we want to go from meters per second to kilometers per hour, here we have 1 meter per second in 1 second. We're going to multiply that by the distance change. So we want to go from meters to kilometers. So what we want to be able to do is cancel our units out. So the meters are going to match up. And that means we are left with kilometers on top, which is the unit we're looking for based on our goal is to get to kilometers per hour. So that is done. We don't need to convert the distance anymore. The other conversion would be going from seconds to hours. So we know that 60 seconds is equivalent to 1 minute. This thing has a value of 1, and we can see here we can cancel out our units of seconds. But now we're left with minutes. We don't want minutes, we want hours. So we have to do one more conversion. We know that 60 minutes are in 1 hour, so now we can cancel out minutes, and we are left with hours on the bottom. So we learned that 1 meter per second is the same as, if we multiply across the top, 3,600 kilometers, because those are the units we're left with on top, over 1,000 hours. Okay, so that's the basic logic behind dimensional analysis, is multiplying by those things that are equal to 1 to get to the right units that we are looking for that match up what we want. So again, noticing going across, units cancel out, you end up with the appropriate units you want. However, the value hasn't changed for the speed, just the units have, because each of those conversion factors is equal to 1. So for another example of that, say we have an electric bill from SDG&E where they charge $26 per kilowatt hour, and we want to know if we have 10 75-watt light bulbs, they're on for 4 hours a day, how much does it cost to run them for 30 days? So what we want to end up with at the very end is dollars. And we know we have this conversion here of dollars per kilowatt hour. So we need to get kilowatt hours. Don't worry about what those units are yet. We'll get to them later in the year, but just so you get an example of how this works. We have 10 75-watt light bulbs. That's a total of 750 watts. Just like with meters, a kilowatt is 1,000 watts. So we know 1,000 watts is the same as 1 kilowatt. Make that a K. So now we've gotten to kilowatts. That's what we need there. But now we also need hours. So we are running this for 30 days. That's the time frame we are being charged for. However, the day here, 1 day, since we need to convert to hours, for this device, for these light bulbs, is only 4 hours long. Okay, we no longer, it's not a 24-hour day for this light bulb because it's only on for 4 hours. So we have taken 30 days and now turn that into hours. That matches up with kilowatt hours. So we have watts gone, days gone. We have kilowatt times hours on the top. So let's get our 1 kilowatt hour on the bottom. And on top, we know 1 kilowatt hour costs me 26 cents. This is again equivalent to 1. The 26 cents is the cost for 1 kilowatt hour. And from there, we could take kilowatts, cancel those out, hours, cancel those out, and the only unit we're actually left with is dollars. So then we would just have to quickly multiply 120 times 750 divided by 1,000, and then multiply that by 0.218 by 26 cents, and we get $23.40. So to run those 10 light bulbs for 4 hours a day, 75-watt light bulbs at that charge, it's going to cost us $23.40 over a course of 30 days. So hopefully that gives you a good idea of how dimensional analysis works and see it in action of units changing.